our viewers. My name is Ehlanzeni. I'm from Ehlanzeni TVET College, Mashishing Campus, Report 191. And today I'm going to present Engineering Science N2. And the topic that we're going to deal on with today is work, power, and efficiency. But before we get into our today's lesson, I hope you have your notebook, your scientific calculator, your pencil, your ruler, because we are going to work together on this topic. And let's start by looking on the key concepts that we need to master in this module. And on these key concepts, we are going to use the theory so that we apply it in practical. Let's start by defining work done. What is work done? Or what comes to your mind when you hear the word work is done? Right. Work done is when force moves through a distance. I want you to picture it in your mind, and I'm here with you. I come here, I hold my pen, and I just stand here. Then I'll look on the clock that what time is it? 5 past. Then after 30 minutes, my lesson must be done. I don't talk, I don't move, I don't do anything. Can we say work is done after 30 minutes, guys? No, we cannot say that because I didn't move, I didn't apply any force, there is no distance that I've covered. So there is no work done. So what are we saying? I'm saying that work is done when force moves through a distance. There must be force applied, like I come here, I talk to you, I move to the chalkboard, I write, I come, I talk to you, you calculate, then there is force and there is distance that I'm applying. Then at the end, we can be able to say work is done. Work done is measured in joules. Then another concept that we need to master is power. What is power? Power is the rate at which work is done. The moment we talk of rate, it means there is involvement of time. And power is measured in watts. And another key concept that we are going to master on today, or we are going to apply, is torque. What is torque? Torque is a product of perpendicular force and distance of the force from the fulcrum. What is fulcrum? What comes to your mind when you hear the word fulcrum? Fulcrum is the turning point, a fixed turning point. That is fulcrum. So torque is a product of perpendicular force and distance of the force from the fulcrum. These are the concepts that we need to master today, and we are going to apply them practical, where we are going to deal with the calculations. But remember, we are doing engineering science. So on this chapter, we need the theory and we need to apply it practical. But before we get to the calculations, we need to master a certain few formulas that we are going to apply. What are the formulas that we are going to use? We defined work done. And here is my formula, work done. It's represented by W, and work done is when force moves through a distance. Meaning to say work done is equal to force times distance. And force F, it represents force, and S, it represents distance. 1 Newton meter is equal to 1 joule. That's why we're saying that work done is measured in joules. Then another formula that we want to look on, when we are talking of force, where is the word force coming from? Force is a product of mass and acceleration. F, which is force, is measured in newtons, mass, it's measured in kilograms, and acceleration is measured in meters per second squared. Because you're going to find in some instances, you will not be given the force, you'll be given the mass. Then you need to calculate the force, deriving it from this formula. Then our next formula that we're going to apply is on torque. We defined torque where we say torque, it's a product of perpendicular force and distance from the fulcrum. So torque is measured in Newton meters. T is the torque, F is the force, and R is the distance or the radius, depending with what you are given on the question. In some instances, it will be distance. In some instances, you'll be given the radius. So these are the formulas that we are going to concentrate on in this module. Now, let's look on the question that we have. I took these questions from a previous question paper. And our first question that we are going to deal with, it says, a machine part with a weight of 13,000 newtons is hoisted up at a building site through a height of 50 meters by means of a chain. The weight of the chain is 60 newton per meter. The question it goes, make a neat sketch of the force distance graph of the lifting process. Use weight for vertical axis and distance for the horizontal axis. That's our first question. But before we get to draw the sketch, there are certain concepts or there are certain things that we need to put down in. First, we read and understand the question. How many objects do we have here? We have two objects. We have a machine with a weight of 13,000 newtons. And we have got a weight of a chain which is used to lift this machine going to the top of the building, which is given 60 newton per meter. We want to deal with this one first before we draw. Let's put down our data. What do we have? We agree we have two objects. The machine, we are given the weight of the machine, which is 13,000 newtons. And we have the weight of the chain. The weight of the chain, weight of the chain, we are given 60 newton per meter. Let's pause there. What are we saying when you say 60 newton per meter? 60 newton per meter, we are saying that this weight 60 newton, it's for 1 meter. But this chain, it has lifted this machine for how long? For 50 meters. So we need to take into consideration that if it lifts this machine for 50 meters, what is our weight of this chain? So we are going to say 60 times 50, so that we'll be able to get the weight of the chain for the distance that it has covered. Let's calculate 60 times 50 meters. What do we get? 60 times 50, we get 3,000 newtons. 3,000 newtons, this is our weight of the chain. Right, now we want to put our total weight, the weight of the machine and the weight of the chain. So we are going to say our total weight is the weight of the machine, which is 13,000 newtons, plus the weight of the chain, which is 3,000 newtons. So what is our total weight here? Let's calculate it. 13,000 plus 3,000. Then we get 16,000 newtons. This is our total weight for the machine. Now, let's look on our question. What are we asked to do? We are asked to make a neat sketch of the force distance graph. So now we want what do we have? We have the force, the total weight of the machine and the chain, and we have the distance, which is 50 meters. Now we are going to put this one, and we are given the hint that the weight, it goes on the vertical, which is our force, and our distance, it goes on the horizontal. With your ruler and your pencil, let's now sketch a force distance graph. On the horizontal, we have vertical and horizontal. Here we are asked that on the vertical we put our weight, which is our force, and we need to indicate that force is measured in newtons. And distance, it's measured in meters. Then, how many objects do we have? We have 2 objects. So we are going to put the bigger force at the bottom and the smaller force on the top. What is our bigger force? Our bigger force is the weight of the machine, and our small force is the weight of the chain. And here we are going to put our weight, which is, it starts on 0. Our total weight of the machine, it's what? 13,000 newtons. And the distance that the machine has traveled, it's 50 meters. So here we are going to put our first force and the distance that it has traveled with your pencil and your ruler, so that your diagram will come out neatly drawn. Right. Then our next weight is the weight of the chain. The weight of the chain is small, so we are going to put it on top of our graph. Then we say the weight of the chain. Remember, we say that the total weight is 16,000. So we are going to put 16,000 as our total weight, so that we'll be able to indicate that the 13,000 to go to 16,000, the difference is 3,000. So on this 3,000, that is the weight of our chain. So here we go. We're going to use a shape of a triangle. Here we go. Then we indicate that this is the weight of the machine. And on top is the weight of the chain. And there is our diagram. Normally, you are guided by the marks that are indicated, but you need to indicate everything that you are given on the question. So here is our force distance graph. Force is measured in newtons, distance is measured in meters, and our distance is 50 meters. The total weight of the machine, 13,000. The total weight of the chain, 3,000, where we say 16,000 minus 3,000, then we get the 3,000 here. Then after we do this, we can say we are done answering the first question. Then we want to move on to the next question. Our next question, it reads as, use the graph to determine the total work done. Use the graph to determine the total work done. How are we going to calculate the total work done? Remember, we say that work done is force times distance. When force moves through a distance, when force, and our forces, we've got 2 forces here, move through a distance of 50 meters. So we want to find the total. When we're talking of total, we are saying the weight of the machine plus the weight of the chain, that is our force, times the distance that we are covering, which is 50 meters. So how do we go about this one? We are going to use a formula for calculating the total work done. I'm going to divide my work here so that we'll be able to refer to the diagram. And How do we calculate work done? Work done is equal to area below the graph, which is area of a triangle plus area of a square or a rectangle. What is the formula for the area of a triangle? Area of a triangle is equal to half base times height plus area of a rectangle or a square is length times breadth. Right, let's look on our diagram here. Our base is 50 meters. So here we are saying half base, which is 50, times our height for the triangle, 16,000 minus 13,000. Our height is 3,000. That is for the triangle. Then for the rectangle, our length, which means we're going up, our length is 13,000 times our base, which is 50. Then let's work it out. Let's calculate half base times height. Half times 50 times 3,000. Let's punch it on our calculator. What do we get? Here, half 50, which is 25 times 3,000. Then our answer on the first one, on the area of a triangle, we are going to get 75,000, right? Plus 13,000 times 50. 13,000 times 50, we are going to get 650,000. Right, let's add 650,000 plus 75,000. What do we get? 650,000 plus 75,000. I got 725,000. Remember, work done is measured in joules. If you are given a question which say, give your answer in kilojoules, then we are going to divide by 1,000. 725,000 divided by 1,000, then we get 725 kilojoules. This is our total work done. Right. Whilst we are there on the total work done, you need to make sure that you check that is it relating all the figures that I'm talking, are they applying on my graph before you proceed. Then after this one, now we are going to proceed to the next question. Our next question, we want to calculate the power required during the lifting process when the load is 25 meters from the top and the velocity of the lift is 1.5 meters per second. On this one, we need to look on what is power. Do we know what is power? Yes, we defined it on our concept that power is the rate at which work is done. That is power. But in this question, we are not given time. We are given velocity. So how do we go about it? Are we still going to apply the formula for power where we say power is equal to work done over time? No. The formula that we are going to apply here now, we are going to apply a formula where we say power is equal to force times velocity. And another thing that we want to look on is we are given the load which moves for 25 meters, according to this question. So here, let's put down first our data so that we'll be able to refer to it. Our distance that is covered is 25 meters. Our distance, 25 meters. and our velocity, which is 1,5 meters per second. Now, we want to refer to our force distance graph, because for us to calculate the power, we say that power is equal to force times velocity. So here we are this is the information that we have. Power is equal to force times velocity. Let's look on our graph of force distance. And 25 meters, it means is the average of this distance, which means it comes on the middle, 25 meters. So before we get to the calculation of calculating the average force, let's deal with it so that we have a guideline of where are we going on finding the average force. So here, average, it means half of 50 here. So with your ruler and your pencil, I want you to dotted line where it ends, then you turn here. You are guided by this, that our answer is between 16,000 and 13,000. So here, let's say probably it's 14,500. We need to prove it by calculating it, right? So here, this is our average force. But let's prove it. That is it true what we are getting. How are we going to calculate the average force? Average force is equal to 0 plus maximum force minus minimum force divided by 2. I'm going to put it here. Average force is equal to 0, which is the maximum, plus maximum force minus minimum force divided by 2. And according to our graph, our 0 is not here at the bottom. Our 0 is where we have the total weight of the machine, which is 13,000. So we are saying 13,000 plus the maximum force is 16,000 minus minimum 13,000 divided by 2. Let's calculate 16,000 minus 13,000. What do we get? 16,000 minus 13,000 divided by 2. Here we are going to say, bring it down, 13,000. 16,000 minus 13,000. Let's punch it. We get 13,000. Then, when we are here now, what are we saying? We are saying that 16,000 minus 13,000, we get 3,000. Yes, 3,000, right? 3,000 divided by 2. So here we are saying 13,000 plus 3,000 divided by 2 is 1,500. So our average force here is 14,500 newtons. This is how we get our average force. Then we look on our graph to prove it that are we on the same spot. Here we say that the average is 25, the middle, then where it ends, then we turn. It's 14,500. And here our average force, after we calculate it, we get 14,500 newtons. Force is measured in newtons. Therefore, we are saying that power is equal to force times velocity. Now we are having our force and we are given the velocity, which is 1,5. So our force here is 14,500 times 1,5. Let's put it on our calculator and see how far we can get. All right, 14,500 multiplied by 1,5. What do we get? We get 21,750. And power is measured in watts. In case you are asked to give your answer in kilowatts. In kilowatts, we divide 21,750 divided by 1,000. 1 kilowatt is equal to 1,000 watts. So here, 21,750 divided by 1,000, our answer is going to be 21,75 kilowatts. Then our last question is saying the turning force of applied to a flywheel is 1,800 newtons. The diameter of the flywheel is 400 millimeters. We are asked to calculate torque, and now we know what is torque. Torque is a product of perpendicular force and the distance from the fulcrum. So our formula here is torque is equal to force times radius. Let's put on the data. What are we given? We are given the force, which is 1,800 newtons, and we are given the diameter, and our diameter that we are given is 400 millimeters. But according to our formula, we say force times radius. So we need to change the diameter to radius. How do we change the diameter to radius? We divide 400 by 2. Then we are going to get 400 divided by 2 is 200 millimeters. That's our radius. But if we look on our formula again, torque is equal to force times radius. And radius is measured in meters. Torque is measured in Newton meters. So we need again to change millimeters to meters. How do we change millimeters to meters? We divide by 1,000. So here we are saying 200 divided by 1,000. So our radius here is 0,2 meters. Now we have everything that we need. We are able to calculate the torque. So our torque is equal to force times radius. And our force is 1,800 times 0,2. Let's calculate what do we get. 1,800 times 0,2. It gives us 1,800 times 0,2. We get 360 Newton meters. That's our torque. So this is what we need to know on this module of work, power, and efficiency. For more information, you can contact us on our website, which is www.ehlanzenicollege.co.za. On our Facebook page, you can contact us at Ehlanzeni TVET College. On our Twitter account, you can contact us at Ehlanzeni TVET. Then on our YouTube, you can contact us on Ehlanzeni TVET College. Thank you so much. May God bless you.